Hey, what's up, chem peeps? What in the heck are we going to do in this video? We're going to define heat and perform calculations involving heat, mass, temperature change, and specific heat. Breaking it down as always. 1. We're going to define heat using the formula Q equals mc delta T. 2. We're going to bust out our algebra skills and manipulate the formula for heat to solve for any of those variables. Alright, so to start this video off, we're going to talk about how we define heat. When kinetic energy is transferred from one object to another, that energy transferred is called heat, which we're going to represent using the letter Q. So what does that letter Q mean? How are we going to define Q? Well, it depends on 3 things. 1, it depends on the mass of the substance that's gaining or losing heat. We'll represent that variable using the letter M. It also depends on the specific heat capacity of that substance. We'll abbreviate that using the letter C. And finally, it also depends on the temperature change that substance undergoes. And recognize that temperature change, or delta T, is described as the final temperature minus the initial temperature. Alright, now the only variable in that equation that I think probably needs a little more explanation is what's called the specific heat capacity. And it's most easily thought of as how much heat is required to raise the temperature of 1 gram of a substance by 1 degree Celsius. Now, take a look at your notes. You're provided with a table of specific heat capacities for some common substances. You're given a list of a bunch of metals, which have relatively low specific heats, and one other one that I want you to specifically focus on is the specific heat of water, which has a relatively high specific heat, especially compared to those metals. And again, think of the units here for specific heat. It's how much energy, how much heat in joules is needed to increase 1 gram of that substance 1 degree Celsius. I have to put a lot more heat into water to get 1 gram of it to increase 1 degree Celsius than I do to increase 1 gram of these metals 1 degree Celsius. Great way to think about that is to think about a pot of water on a stove. The metal pot is going to get hot really quickly, but it takes forever to get the water to boil. You have to put a lot more energy in order to get that water to increase a degree Celsius. Again, as you think about trying to wrap your mind around the idea of specific heats, compare those 2 things. Metals have relatively low specific heats, while water has a relatively high specific heat. Alright, so we've talked about this in terms of mass, but realize this equation can also be used to define heat in terms of moles. Only difference being is that we'll be using moles instead of mass, and your specific heat capacity is going to be given as the molar heat capacity, and so your units are going to be joules per mole degree Celsius instead of joules per gram degree Celsius. Temperature change is still the same, T final minus T initial, and recognize that solving the equation is the same. Just be conscious of your units. Alright, now let's talk about the sign of heat. The sign of heat, or Q, can be either positive or negative depending on whether heat is transferred into the substance or out of the substance. Recognize that a positive Q value indicates that heat is absorbed, and a negative Q value indicates heat is released. It's important to recognize that the sign of Q is simply indicating the direction of heat transfer. You can't have, for example, a negative amount of energy. It's just indicating the direction of that heat flow. Let's come back to this thrilling animation. Once again, I'm going to use a beaker of water and a block of iron. I'm going to heat up this block of iron. Woo, yeah! Let's get it nice and toasty. I want you to think about the direction of the heat flow as I place this iron block into this beaker of water. Here we go. Iron block into the water. Oh man. Notice that the heat flows from the hotter iron block into the cooler beaker of water. So the sign of Q, or the sign of the heat absorbed by the water, is going to be positive, but the sign of the heat released from the iron is going to be negative. Again, those signs are just going to indicate for us whether or not the heat is absorbed or released. Alright, and then finally, recognize our units for heat. Most commonly, because our specific heats are given to us in either joules per gram degree Celsius or joules per mole degree Celsius, our final unit of heat is going to have the energy unit of joules. However, recognize that we can also use calories or kilocalories as units of heat energy, and you want to be comfortable with converting back and forth between those different units. Alright, that does it for this video. Have a fantastic day.